In today's class, we'll be learning about product metrics. So, basically, we'll be dealing about the framework for our product metrics. So, a fundamental framework is a set of basic principles for the measurement of product metrics for software which should be established. So, when we talk using the terms in software engineering, there are four terms to be remembered. The first one being the measure, which provides a quantitative indication of extent, amount, dimension, size of an attribute of a product or a process. So, measure is basically used to establish whether a single data point has been collected or not. The second term we come across is measurement. It is an act of determining that measure, and it occurs when one or more data points are collected. Third is the metric. It is the quantitative measure of the degree to which a system, component, or a process possesses a given attribute. So it relates to individual measures in a way. And the last one is the indicator. It is a metric or a combination of metrics providing directly an insight into the process of software project or in the product itself. So there is a basic need for understanding the measure and to control the software complexity. So one should be aware of all these four terms, and it will help them to develop measures of different attributes. These measures and metric can be used as independent indicators of the quality of analysis and design models. So, product metrics assist in evaluation of analysis and design models, gives an indication of the complexity, and also facilitates and helps to design much more effective testing, and that's the reason why steps are to be followed while taking these effective measurement process into consideration. So the series of steps include formulation, which means the derivation of software measures and metrics. Collection is a way to accumulate data required to derive the metrics. Analysis is the computation of metrics. Interpretation is the evaluation of the metrics. Feedback is the recommendation derived after interpretation. So you can remember all these 5 points with the first word associated with it, that is formulation, then collection, then analysis, then interpretation, and at the last feedback. Now we look on further of the characterization of the metrics and the validation includes. So metrics should have a desirable mathematic properties. The value of metric should not increase or decrease in a manner in which a software characteristic increases when positive trait occurs or decreases when undesirable traits are encountered. So if we look into the graph of metrics, you'll see a upper parabola to be considered, because the value should neither increase nor decrease in a manner where its positive trait occurs to be decreasing or increasing when undesirable traits are encountered. And that's the reason why it's said metrics should be validated empirically. Now we move forward to the next topic, that is metrics for the requirements model. So the metrics for the requirement models both rely on measuring and reporting the scores of metrics used to quantify performance of particular process. So while using it, the scores differ based on the business processes being monitored, and therefore there are certain characteristics that are common to the concept of metric. And in turn, the individual metrics can be grouped together into a high level scores computed as functions of the individual component measurement. At the most basic level, a metric represents a quantification of a single score to answer a specific business question, which means that the basic level of metric can be simple as a count. And therefore it is very much of importance to remember that every metric is intended to answer at least a one business question, which therefore makes it defining a model or building a system that analysts must engage the business users to help in clarifying, identifying, rectifying indeed, and also documenting specific business data needs for the system. So this whole process requires the interviewing key system stakeholders, and customers to clarify business process and needs as prelude stakeholders and customers to clarify business processes and needs as to preload to synthesize the requirements for the system model. This anyway incorporates the reviewing, analyzing, integrating the system information and the stakeholder interview data to create key artifacts such as the fact or qualify matrix that will hence derive and drive the definition of the model and providing the determination of data sources to populate the model. And the process for presenting the metric information is then again given back to the business users who are using the specific model, that is requirement model in this case. Now we go further, that is the metrics for a design model. So metrics simply measures the quantitative assessment that focuses on countable values most commonly used for comparing and tracking performance of a specific system. So metrics here include different scenarios like analyzing, design, source, testing and maintenance. So this is the basic definition as you have seen for metrics. And now we'll deal about metrics for design modeling, which allows developers or software engineers to evaluate or estimate quality of a design and include various architecture and component level designs to it. So here is one class of metrics for design model, that is metrics by class and card. So in designing a product, it is very important to have efficient management of complexity. Complexity itself means it's very difficult to understand. So by the use of such system, it's generally very complex so as to connect to many of the components. So Glass and Card are two of the scientists who have suggested simple three design measures. So one of them is structural complexity. So structural complexity depends upon fan out of modules. So fan out here means it's a number of modules that are there in subordinating module K. So it can be defined in the form of S of K equal to F square of K out. So where F out represents the fan out of module K. The second one is a data complexity. Data complexity is complexity within the interface of internal module. So it is the basic size and the intricacy of the data. For defining some module K, it can be defined as d of k equal to total var of k by f of k out plus 1. So this is the form for d of k, calculating the d of k, where the total variable or total var is the total number of input and the output variables going to and coming out of the module. So we have taken k as the module. So system complexity is, it's a combination of structural and the data complexity. So it can be denoted as sy for system syk equal to s of k plus d of k. So when structural data and system complexity gets increased, the overall architectural complexity also gets increased. Now we see what is complexity matrix. So complexity matrix is used to measure how much complex is the overall software. So the computation of such complexity matrix can be done with the help of a simple flow graph. And this flow graph is called cyclomatic complexity. The cyclomatic complexity is useful metric to indicate complexity of software system. So without the use of complexity metrics, it becomes much more difficult and time consuming to determine how much complex a particular software is while designing its product. So measuring software complexity leads to improved code quality, increased productivity, it meets the architectural standards, it reduces the overall cost, increases robustness, etc. So these are the advantages while using the complexity metrics. So now to calculate the cyclomatic complexity, there is an equation. So the equation says that cyclomatic complexity is equal to e minus n plus 2, where e is the total number of edges and n is the total number of nodes. Now we look on into a very simple problem. So in diagram as given below, you can see there are number of edges and number of nodes. So for the statement, here's a simple code which is a syntax of code. Statement 1, if condition expression 1 inside their brackets, then statement 2 block of statement, and else condition, then statement 3, then statement 4 in the do while condition loop, and statement 6 finally. So if you represent this in a flow in the form of flow chart, the following algorithm, and the same has been depicted much more easier in a way in the flow graph next to it. So in the flow graph you can see the correct number of edges and the number of nodes. So it can be calculated that the number of edges is E equal to E moves from E equal to 1 to E equal to 10. So there are total E equal to 10, and the total number of nodes that are present depicted in the flow graph is 8. As you can see, these are the nodes n1, n2, n3, n4, n5, n6, n7 and n8, and the edges are the following pointers, that is e1, e2, e3, e4, e5, e6, e7, e8, e9 and the e10. That is the condition, that is true false, and when it's calling when it's pointing to the next step, so that can be referred to as an edge. So we have seen the cyclomatic complexity. The statement, its equation is E minus n plus 2. So to find out the cyclomatic complexity, the final answer would be 10 minus 8 plus 2, that is 4. It's as simple as that. Now we move forward to know what is design metrics for web apps. So many of the web applications have often evolved from simple HTML pages to complex application to have high maintenance cost. So this high maintenance cost is due to the heterogeneity of web application. That means its changing ability of one page to another using high complex application. So this has been imposed in short development cycles and frequent modification. So in order to control such kind of maintenance cost, quantitative metrics for predicting the web application have been used. So this paper provides an exploratory study for new design metrics and can be also used while dealing with the maintainability of web application from classic diagrams. So the complexity, the size, the coupling and the reusability can be measured using this type of metrics. Now we'll see the most keywords, that is the web application metrics, maintainability and UML. So there are two laws to be kept in mind while dealing with the software evolution laws for handling the web apps. First law, continuing change. A program used in the real world must always change or eventually it will become less useful in the changing world. The second law, growing complexity. As a program evolves, it becomes more and more complex and extra resources are needed to preserve and simplify its nature. So this is a diagram through which you can better understand how it looks like. So there are server page, there's a web pages. So as and when the program or as and when the software evolves, you need to put extra resources onto it so as to preserve its nature and to simplify the code or simplify the software so that it becomes much more efficient to the business users. Now we move forward to know what is the web page. So you can see here that a web page is a primary element of a web page application. It is modeled with two separate stereotype classes, the client page and the server page. The client page contains client-side script and the user interface formatting. The server page contains server methods and page scoped variables. Forms. Forms are defined to separate the form processing from the client page. The form element contains field elements. Forms are basically contained in client pages. Each form submits to a different action page. So now components. Components run on the client or server page. ActiveX controls and applets are some of the examples of the components. Now we'll see what is scriptlet. A scriptlet is basically a place where references to components are controlled, and it's controlled in such a way that it can be reused once again by the client pages. So now we'll go to frame sets. A frame set divides the user interface into multiple views, each containing one web page. Frames can contain more than one client page, but they must always contain at least one client page. So now we'll see what is an XML. So an XML element is hierarchical data representation that can be passed back and forth between client and server pages. So this is a very important table that is towards your right. That is the web application design metrics and the characteristics of web application. So while asking the question, like the question will be like, mention some of the characteristics of, you can find the answer to that question. So here are the characteristics of web applications. The characteristics, some of them are application domain age, lines of code language, web server, till design tool. So you can list some of the characteristics using this diagram of web application. And the above diagram represents the description to metric type, that is size. Total number of server pages, the term used is end server P. Total number of client pages, term end client P. Total number of web pages is the additional amount of both of the above client pages and server pages. So like that, there are metric type for structural complexity, control coupling, data coupling and reusability. So you need to know the description of it and also the formula related to it. Now we move forward to know the metrics for source code. Source code metrics are essential components in the software measurement process. They are extracted from the source code of the software and their values allow us to reach conclusion about the quality attributes measured by the metrics. Our approach to source code measurement through a framework. So there are framework requirements for approaching a metrics for source code. So such source code depend upon naturally the functionality to compute and to interpret a set of metrics. The computation of these metrics should be done in such a way that it is possible for a user to tune the computation of the metrics in accordance with the context, which means that the combination should also be available in a manner of context or a language to the user so as to have the ability to change or update them and to define new combinations that are much more suitable for his or her purpose. So this type of configuration help in determining the context. However, it might also turn out to be tedious and lengthy to be done by the user itself. So the user may not have the needed knowledge to how to determine such type of settings. For that you should be framing a framework so that it can employ a convention over configuration policy and help it provide sensible out of the box configuration for often recurring context. Now we'll see how is the designing and the structure of framework included. So among the key ideas of the proposed framework, there should be a base set of metrics. The base set of metrics simply means that the values are computed by the framework itself. So the user is not given the ability to define new metrics except for metrics combining measures from the base set of metrics, which makes it much more easy to the user to access. So there are a set of types of function that are there in the framework. They are metric function, preprocessor function and evaluation function. So metric function specializes in the extraction of the value of a single matrix from the set of metrics for a given code unit. Thus for every metric in a base set of metrics there is a corresponding metric function which helps in taking the parameter from the source code and artifacts needed to produce the corresponding next level metric value. Now what the preprocessor function does is that it prepares the parameters that is taken by using the metric function and these parameters are given a preprocessor function to it. So typically the preprocessor function implements the filtering of the artifacts used for the computation and also helps in giving the value to include inaccurate in some context. So the evaluation function is here used to combine the values of the metrics from the base of set metrics to a value to custom metrics and hence it forms an anti-pattern. So they are useful to combine measures in a meaningful evaluation of a code quality. Now this is what a simple diagram of testing of metrics looks like, where you can see there are scope, quality, cost, schedule all under the term quality. So software testing metric is defined to be the quantitative measure that helps to estimate the progress, quality and the health of software testing effort. So such type of metric defines in a quantitative term to a system component and process to process a given attribute. So this is an ideal example to understand the metric. So why is test metrics much more important? See, we cannot improve what we cannot measure. So test metric is used to test, and then after testing we come to know what is to be improved. So to understand the same, we have a set of 4 points, that is, take decision for next phase of activities, evidence of the claim of prediction, understand the type of improvement required, take decision of process or technology change. So first process metrics, then product metrics, then comes the project metrics. So there are three type of metrics, and the process metrics is basically used to improve the process efficiency. Product metrics is used to deal with the quality of the software product, and project metrics is used to measure the efficiency of the project team or any of the tools that is used for testing by the team members. So there should be identification of correct testing metrics, and these are to be considered. Fix the target audience for metric preparation, define the goal for metrics, introduce all the relevant metrics based on project needs, analyze the cost benefit aspect of each metrics and the project lifestyle phase in which it results in the maximum output. Now we'll see the metrics for the maintenance. Effective maintenance of equipment is very critical factor in delivering quality operation that provide timely resources at a minimal cost. So the maintenance field takes the role of understanding the equipment's reliability, and it does not come much easy. So it handles all the maintenance that has to be done of the software needed. So maintenance matrix is divided into two categories to be known, so that they can perform indicators which include the leading and the lagging indicators. The leading indicators signal future events and the lagging indicators follow the past events. So this helps in knowing and maintaining the software much more ease. So here we'll be dealing with 5 points of how the steps are taken for maintaining the metrics. So first is the planned maintenance percentage, second is overall equipment effectiveness, third being the mean time to repair, fourth mean time between failure, and fifth is the preventive maintenance compliance. And the final part of conclusion regarding the maintenance metrics is the best way to track if your actions have a positive impact on your maintenance operation is to accurately track metrics that can show you if you're going in the right direction. So the final part, which is very important to know, is the best way to track whether you're going in the right direction is to have a check on each of the operation, so that you can accurately track your metrics, and it will help you improve and lead in the right manner. That's it. Thank you.